Dear students, in this video you are going to learn 10 short answer questions in less than 10 minutes. Okay, today we cover unit 1 and these are the basic level answers and you are expected to include what you have learnt in our regular classes. Okay, don't forget to do that. Question number 1, define common mode rejection ratio of an operational amplifier. The common mode rejection ratio CMRR is defined as the ability of an op amp to reject common mode signals. That is CMRR equal to 20 log to the base 10 mod ADM by ACM. What is ADM? Differential mode gain. ACM common mode gain. Next question, question number 2. Write any two characteristics of an ideal op amp. An ideal op amp maintains following characteristics. Many are there. Two we are mentioning here. One, gain is infinity, and two, bandwidth is also infinity. What is gain? We know that gain A is equal to V0 by Vd, that is output voltage by differential voltage, and A is equal to infinity. That means V0 by Vd equal to infinity, and to get V0 by Vd infinity, Vd must be 0. Therefore, Vd equal to V1 minus V2 is equal to 0. So, V1 is equal to V2. Here by mistake it is written V1 by V2 equal to 0. It is not V1 by V2. It is V1 minus V2 equal to 0. Okay. And second parameter, that is second characteristic, bandwidth equal to infinity. That is the range of frequencies over which gain is constant is called bandwidth. Okay. And question number 3, list the DC characteristics of an op amp. So, the behavior of an op amp when constant input voltages are applied is referred to as DC characteristics, and for an operational amplifier, DC characteristics are listed below. What are those? We know many, but few we are mentioning here. Input bias current, input offset current, output offset voltage, input offset voltage, thermal drift, CMRR, PSRR, etc. If possible, you also define these with the basic definitions. Question number 5. What is the slew rate of an op amp? So, the maximum rate of change of output voltage of an op amp as a function of time is called slew rate, and slew rate is equal to dV0 by dt. So, it is mentioned in volts per microseconds, and ideal value all that you please add. Question number 4, that means the order is changed. Next question, define power supply rejection ratio of an operational amplifier. So, the ability of an op amp to reject variations in power supply from affecting the output voltage is called power supply rejection ratio. Change in delta change in supply voltage by change in V0 is called power supply rejection ratio, and 3 different definitions I have given in the class. You please include those. Question number 6, what is the function of a differential amplifier in the internal block diagram of op amp? First you draw the block diagram and then you just mention this. The differential amplifier in the internal block diagram of an op amp serves as the input stage, and it amplifies the difference between the two input voltages applied to the inverting and also non-inverting input terminals. Okay. Question number 7. Mention the purpose of level shifter in the internal block diagram of op amp. Okay. So, here also you draw the block diagram and then you write. It is an emitter follower with the constant current which is used to shift back the DC level of output voltage towards ground. Okay, and you draw the block diagram and explain, right? Question number 8, mention the purpose of output stage in the internal block diagram of op amp. Here also you can draw the block diagram first and then you can write. It is a push-pull amplifier. You know, output stage is a push-pull amplifier and which is used for the following purpose. What is the purpose? To provide low output resistance which increases the driving capability of op amp at its output. Then question number 9, define voltage regulator and list the 3 terminals of a voltage regulator IC. Right? A circuit which produces constant output voltage irrespective of fluctuations in supply voltage or output load is called a voltage regulator. Okay. Then the 3 terminals of voltage regulator ICs are in general are input pin, output pin and ground pin. You take any one IC number, either positive regulator or negative regulator, and you mention these pins. Question number 10, state the need for an instrumentation amplifier. So what is an instrumentation amplifier? You mention first and you draw the diagram, then you write an instrumentation amplifier is needed to amplify low level digital signals in the presence of common mode noise. Okay, and it provides high input impedance, excellent noise rejection, and it is accurate, and it has easily adjustable gain. So with this we have covered 10 questions from each unit, and other unit short answer questions are also available in the playlist. You please go through, and we thank our friend for her handwriting and also patience in writing all these 50 questions and answers, and we give special thanks to her, and I wish you all the best, and you please make use of the available information. Thank you. God bless you.